Yeah, just we are going to start with the next session on this materials of polymers, ceramics and composites. Good afternoon everyone, myself Professor Dr. Sandeep Ogol. Today in this session we are going to see, again in the previous session we have studied the classification based upon origin of the polymers. We have classified them in natural, semi-synthetic and synthetic. Then in the second session we have seen the classification based upon the manufacturing. We have seen the two fabrication or manufacturing processes in that, or polymerization processes you can call it as. That is again addition polymerization and condensation polymerization. Now in this class we are going to learn something about the classification based upon the structure. So as you can see that it is linear polymers, branch polymers and cross-linked polymers. Linear polymer means what? You can simply having one continuous line of the polymeric chain. That is considered as a linear polymer. Then second one is the branch polymer. That means the linear chain is there and that chain is having certain branches, like a branches of tree or something like that. Okay. And the third one is cross-link, means there are two parallel chains of the polymers and these two parallel chains are getting connected with another link in between that two, that is called as cross-link. So there, if you see the linear polymers, they are having high density polythene. Our example is high density polythene, polyvinyl chloride. Then example is low density polymer. For branch one, the low density polymer is there, and for crossed one, the bakelite or melamine is there. So if you see in detail, here in the linear structure, the monomers are linked together to form the linear chain. The van der Waals interaction takes place between the two chains. That means these van der Waals interactions or van der Waals forces are there, which are considered as a weak forces. Okay, they can be formed in this one. That means two monomers are going to be connected with the help of these van der Waals forces, and they form the linear chain. The common examples are like nylon, high density polyethylene, polyvinyl chloride, and polyesters is there. Then the second one is branched, where you can have a branches like a tree kind of thing. So one main branch is there, and backbone you can call it as, when main branch will be there, and some branches to that particular main linear polymer it will be there. So example, these are also the monomers are joined to form long chains with branches of different lengths. So low density polythene, polyethylene and glycol and starch are the example of this one. And the cross-link structure, if you see, the monomers are combined together to form the cross-link chains. These chains are connected by covalent bonds. The covalent bonds are more stronger than the van der Waals forces. Okay. So here you can see the example is rubber and bakelite is the example of this one. And if you see the diagrams of this, here you will see. So this one is the linear polymer, only one line is there. This one branch, A, B, C type branches might be there. Okay, so here you can have some different types of branches, and the cross-link means you can see here three polymers are parallel to each other and they are cross-linked or they are connected with the help of links. So these, in this case, in chain polymer, whatever the forces which are there in between the two monomers, that are van der Waals forces, and in the cross-link one, you can see that these are the covalent bonds. So these are covalent bonds are again more stronger than the van der Waals forces, and that is again another reason to more strength, to have more hardness or tensile strength of these cross polymers as compared to the chain polymers. Okay. You may have a question on this, like give the classification of polymers based upon structures with suitable example. So here this slide is there, examples are also listed, and the diagram is expected in that particular answer. Then the next type of classification is based upon the type of repeating units, matlab type of monomers. If their same ethylene is going to connected, then it may become polyethylene. So monomers are same type. So that kind of monomers are called as homopolymers, or polymers formed from the same kind of monomers. They are called as homopolymers. Homo means same. So here when a polymer is formed only one type of monomer, that is in its structure only one type of repeating unit is present. For example, polyethylene. In the polyethylene only ethylene monomer is going to be there, which is going to be connected. Okay. So in that case we can call that particular polymer as a homopolymer. Homo means single or same type of monomers are going to be there. Examples are also given: polyvinyl chloride, polyethylene, polybutadiene, or these are the examples. And what do you mean by copolymers? Obviously, the monomers are of different types. Monomers are of different types. The polymer which is made from different types of monomers coming together to form the polymer, that can be called as a copolymer. Examples are also given as polyethylene copolypropylene, polystyrene cobutadiene, and polyacrylonitrile cobutadiene costyrene. So that means here you can see that polyethylene and polypropylene are coming together. That means these two monomers are different, and from these two monomers we are going to have a polymer. When polymers are formed from more than one type of monomer or more than one type of repeating unit are present in the structure of the polymer, then they are termed as copolymers. Okay. So you have to understand the basic difference between homopolymers and copolymers. Homo means the monomers are of same kind of, or repeating units are of same kind of. In copolymers they are not same, they are different. Okay. And the example is also there. Again, same kind of question might be there. Classify the polymers based upon repeating unit or based upon the monomers. So these two classification points are there and their examples are there. And quite obvious, when the two, for example, in copolymers, if the order of arrangement of that monomers, that is also going to be important. So how that monomers are going to be, or what kind of repeating units, types of repeating units are there, or how they are connected with each other, or how the chain is formed. If there are two monomers, for example, A and B are the two monomers, then how they are connected with each other, whether they are connected as randomly, okay, or whether they are following some order for making that particular polymer. So based upon that, random, alternating, block and grafting copolymers are there. Okay. So in random one, when two or more number of monomers are there, they are just connected with each other randomly. There is no any certain kind of order is to be followed during the formation of that particular copolymer. कि कोई भी orderly नहीं, कैसे भी आओ और एक साथ polymer की chain में आ जाओ, ठीक है? Then alternating, that means A B A B A B A B kind. That means there is certain order during the polymerization technique or polymerization process. The formation of polymer is formed by the alternating arrangement of monomers. For example, if A or B are the two monomers, then A B kind of arrangement of that particular monomer in the polymer will be there. Block one means A दोनों दो A का block रहेगा, B का रहेगा, A का रहेगा, B का. मतलब in groups, they might be in groups. So that is one more arrangement of the monomers in copolymers. And graft copolymers. This type of copolymers essentially consist of two or more homos polymers. मतलब इसमें graft copolymers में क्या है? दो और दो से ज्यादा क्या है आपके homopolymers है. That means monomer will be of same type. Okay. So here in such a fashion that one homopolymer is covalently attached or grafted as a long chain branch to the backbone of the other homopolymer. मतलब दो homopolymer है, उसमें एक homopolymer covalently दूसरे homopolymer के साथ attach हुआ है like a backbone. Okay. So with the diagram you will understand easily. Here you can see that alternating copolymer. If the two monomer units are there, one is this, one is this. So they are connected alternately. Randomly, there is no sequence of connection. Randomly oriented or randomly attached with the other monomers. Then block. So same block in combination. जैसे गट्ठे में एक साथ जैसे. and the grafting. This is one type of homopolymer. See, the same monomers are there. Same monomers are there. And grafting means what? The other homopolymer is there. It is connected to the first one like a branch. Are you getting my point? This is another monomer. This is another monomer. As a polymer, this is homopolymer. This is also another homopolymer. But the second, whatever the homopolymer, one will be as a backbone, and the remaining second homopolymer will be connected to the first one in the form of branches. Okay, so here that is what they are saying. यहाँ पे पढ़ने से हमें समझ में नहीं आता है, but when we see the diagram, then we can understand. So in such a fashion that one homopolymer is covalently attached, grafted as a long chain branch to the backbone of the other homopolymer. Okay. Then here you can see that. So this is the diagram. So again, I may have a question that what are the different types of repeating unit and how they are. How the arrangement of the repeating unit is done, or what are the different possible arrangement of repeating units in polymers. What are the different types of repeating units and what are the different combinations or arrangement are possible in that repeating units. This kind of question may be there. And the last classification is based upon its physical properties. Okay. Last classification of, so as far as our syllabus is concerned, for polymers we have seen the classification along with the examples also, and we have also talked about certain properties of the polymers. Okay, so here you can see that based upon physical properties, they are classified as three classes. One is rubber or elastomers. Okay, second one is plastics, and the third one is fibers. So based upon the physical properties, polymers are classified into three categories: rubbers or elastomers, plastics and fibers. Now you can hear every examples are given and also the properties of that particular are given. So if you say for rubber, this class of polymers are easily undergo very high and reversible elongation under relatively low applied stress. That is, they have long range of elasticity. Rubber. हमें ऐसे थोड़ा भी खींचते हैं तो it will get extended. So elasticity is good. This is the reason why they are also known as elastomers, and the characteristics are given. Now, if you see the properties, they are having high molecular weight, amorphous polymers with low Tg. That is, what is this Tg? It is a glass temperature. Rubber कैसे बनता है? Tg is glass below the room temperature. That is again glass temperature. They are having high chain flexibility and low secondary forces among the chain molecules. Okay. So as far as properties of elastomers or rubbers is concerned, they are having high molecular weight, amorphous polymers with low Tg. That means glass temperature. Okay. Then high chain flexibility. We can have more flexibility in case of rubbers, and also have low secondary forces among the chain molecules. If there is a branched or cross-linked polymers are there, but in that case also the secondary forces or van der Waals forces or covalent forces, therefore their forces may be low. Then the mechanical strength of the rubber is also low because of its low inertia or intermolecular forces of attraction. Rubber के molecular forces that is kind of a van der Waals forces present in that particular one. That's due to that forces available in the molecular structure, the overall strength of the rubber is going to be less due to the low intra or intermolecular forces of attraction. Then the third one is the dimensional stability can be obtained through chemical cross-linking called vulcanization, or through blending with other plastics called thermoplastic elastomers for their end application. Now, if we want to prepare a rubber material for making a tire of a vehicle, okay, we know that it is very strong and it will go around 3-4 years depending upon your driving and running distance. But in that case also here you can see that these rubbers can be made hard by addition of some other materials, like you can blend it with the other plastics so that it will become strong, or you can have a vulcanization process. Okay, in the vulcanization process again you can increase the dimensional stability of that particular rubber material, and that's why we can able to prepare that particular tires for vehicles can be prepared by this kind of processes. Natural rubber, polybutadiene, polychloroprene, styrene butadiene, copolymer, etc. are the few examples of such polymers. Okay. Again, explain the properties, examples, and examples of rubber elastomers. Same thing will be with the plastics. Same thing can be with the plastics. These polymers, possesses much higher intermolecular forces forces of attraction than rubber, but extensibility is lower than elastomers. Matlab, elasticity will be lower than the elastomers or rubbers, but if you see the strength, if you compare the strength of rubber and plastics, these are more stronger than the rubber because of intermolecular force of attraction between the molecules. That forces are strong enough or more, that's why their strength is also more. Strength properties of plastics are higher, but elongation at break is lower than the rubber. That means elongation is less, but at the same time strength is more. Have sufficient dimensional stability. There is no need to cross-link them with the end uses. They are going to have the sufficient cross-linking is there, so there is no need to add any extra material as a cross-linking material into that, so that its strength is going to increase. So basically these are more stronger than the rubbers. Why? Because their cross-linking is actually present there. We don't have a need to add another material or plastic to produce or to introduce that particular cross-linking into that, because it is already having there. So that's why the strength is more. Possesses certain degree of crystallinity and Tg is above room temperature. मतलब glass temperature is above room temperature. Elastomers में glass temperature below room temperature है. Plastics में glass temperature above room temperature है. So that is the reason they are having high degree of crystallinity. मतलब plastics जो भी आप ये देखते हो मॉल में अगर आप जाते हो या वहाँ पे acrylic sheets वगैरह जो देखते हो, that is a kind of a plastic which can be made from this kind of polymers. Then their processing is comparatively easier than elastomers as they become softer on heating without decomposition and transform to dimensionally stable hard material on cooling. Like for example, you can take that example of acrylic sheets, a kind of plastic material, but it will have good dimensional stability. It will also have, and it can have a strength as well. So dimensional stability is also there, and along with that the strength is also there. इकडे लक्ष द्या, खाली काय बघताय, किती वेळ झाला? सकाळी का नव्हतं लेक्चरला? मग काय विचारायची पद्धत आहे येऊन? का उशीर झाला? घरच्यांनी काम लावलं होतं ना? बरं आलंय ते आलंय, खाली मान घालून स्वतःच्या दृष्टीत होऊन जायचं. पुढे बसत जा नाही तर. Okay, processing is comparatively easy because again there is no need of addition of any cross-linking material because it is already there, and dimensional stability is also good, and during heating they become easily soft. Okay, then we can have some, if there is some instability in the dimensions, we can heat it again, we can make it the dimension okay, and then we can use it, and again there is no compromise for the strength as well. So its strength is also more than the elastomers or rubbers. They can be easily recycled and reused, like a thermoplastics, kind of a thermoplastics material you can have. So either polyethylene, polypropylene, polystyrene, PVC pipes and everything, there are some examples of this plastics. And the last one is here, the fibers. These polymers have highest strength and crystallinity, but the lowest elongation among these classes of polymers. Strength सबसे ज़्यादा है, मतलब इलास्टोमर से भी स्ट्रेंथ ज्यादा है, प्लास्टिक से भी स्ट्रेंथ ज्यादा है, बट एट द सेम टाइम अगर स्ट्रेंथ हमें पता है, वी हैव सीन इन मैकेनिकल प्रॉपर्टीज ऑफ स्टील मटेरियल्स दैट इफ यू वांट टू इंक्रीज द स्ट्रेंथ यू कैन नॉट इंक्रीज द डक्टिलिटी, और you have to do something to have that two properties in balance. But as far as if you see the thumb rule and all that, if you want to increase the strength of the steel material, at the same time you have to compromise on ductility. Likewise, the same thing is applicable here only. Here also, the strength of the fiber is more, but at the same time their ductility is less, or crystallinity is more, but elongation is what? We are going to measure the ductility in terms of elongation, percentage elongation. So यहाँ पे percentage elongation कम है, but at the same they are having highest strength. These polar polymers have very high intermolecular attraction forces among the chain molecules. That means covalent bonds are very strong. जो bond बन रहे हैं, cross linking जो बन रही है, that is very strong. That's why the strength is more. Polar, induced polar or H bonding, etc. along with the van der Waals forces as well. The Tg is much higher than the room temperature. That is, glass temperature is much more higher than the room temperature, and they must be drawn into filaments like fibers by solution or by melt spinning technique. That means we cannot have a fiber like at a long length because elongation is less. We have to make it in a branches, or we have to make it in some segments so that it can be used in composite materials. Composite material में जब आप carbon fiber, for example, carbon fiber is there. So carbon is the base material of that particular one, and that carbon is going to be incorporated with the help of these fibers, which are going to increase the strength of that particular carbon fiber. That we are going to see in the composite part as well. Thus, fiber forming polymers are highly symmetric, linear and high molecular weight polymers. Nylon 6, nylon 6,6, Kevlar, PET, etc. are the few examples of fiber forming polymers. Okay. Any doubt in this? I think it is more than sufficient as far as polymers are concerned. We have seen all the classification in detail. Okay. So, and along with that, properties and some examples or applications of that particular polymers we have also covered in this particular session. Any doubt? If you have any doubt on this, you can ask. समजतंय का काय चाललंय? काय अजून एक लेक्चर करायचं त्याच्यात लोड आलाय. आज कुठले लेक्चर होते? म्हणजे आज सगळं मटेरियलच आहे का फक्त? मध्ये काय होतं लॅब? चांगलंय मग. उलट आनंदी व्हायला पाहिजे तुम्ही लोक. नाही चेहऱ्यावर तर वाटत नाही. जेवण केलं सगळं नक्की? झोप येते काय? कुठे गेलं झोपणारे काय करणार? तिकडे बसलाय पण आज आहे जागत. आणि माझं लॅबचा कन्सर्न आहे. मला 211 मध्ये थंडगार वाटतं, त्यामुळे एकदम गाढ झोपे जातो आम्ही. ठीक आहे. इज इट एम आय गोइंग गुड गाईज? म्हणजे जे चाललंय ते व्यवस्थित चालू आहे. आता काय सर सगळं जे वाट लागायची लागली ना, अजून चांगलं वाईट काय ना तर नाही. सगळ्यांची जी काही अटेंडन्स सिम्पोजियमची लावायची होती ती लावली गेलेली आहे. मार्चच्या अटेंडन्स मध्ये ते सगळे क्युम्युलेटिव्ह अटेंडन्स मध्ये येईल. ठीक आहे. नाउ लेट्स मूव फॉरवर्ड टू द ceramics. What do you know by ceramics? Any information about the ceramics? इथलं काढतो मी, म्हणजे आम्ही इथलंच वाटतो. I just want to know from you guys that what do you know about the ceramics? What the word ceramic means? काय? अरे त्याच्यात तुम्ही पण काहीतरी बोलताय असं आलं पाहिजे. त्याच्यात क्लासमध्ये लेक्चर घेताय असं आलं पाहिजे. सिरामिक कोटिंग. ओके. सिरामिक कोटिंग. ओके. अजून combination of metals and non-metals. That comes under category of composite materials. वापरता का तुम्ही सिरामिक्सचं मटेरियल डे टू डे लाईफ मध्ये? चहा कशात पिता? चहा कशात पिता? सिरामिक मटेरियल ग्लास मध्ये पिता, पण कप असे असते ना. व्हॉट इज दॅट? सिरामिक मटेरियल. हाऊ इट इज फॉर्म? हाऊ इट इज मेड ऑफ? mixture of powders, for example. Don't go in detail metals and non-metals and all that. Powder. Then how the earth pot is going to be prepared? Can we take earth pot as an example of ceramic? Huh? So what is the making process of earth pot? किती जणांनी गावाकडे बघितलं कुंभार बनवलेलं आहे किंवा आजकाल फॅशन आहे रिसॉर्टवर गेलं तुम्ही कुठं की तिथं ते बसत असेल फिरवत बसलेले असतात आणि बनवा म्हणतात तुम्हाला मग आम्ही आमचं स्किल तिथं लावतो हाऊ इट इज प्रिपेअर्ड अरे माती घेतली जाणार ते मिक्स केली जाणार मग ते चाकावर ठेवलं जाणार त्याला शेप दिला जाणार मग पुढं काय केलं जाणार उन्हात ठेवलं जाणार बरं वाळलं त्यानंतर काय होणार फर्नेस मध्ये टाकणार भट्टीमध्ये टाकणार ते का टाकायचं भट्टीमध्ये कडक होतं म्हणजे काय होतं जरा टेक्निकल लँग्वेज वापरा की थोडी कडक होतं म्हणजे काय मातीमध्ये ज्यावेळेस तुमचे वेट कंडिशन मध्ये असतं त्यावेळेस जे पावडर पार्टिकल असतात ते दे आर जस्ट टचिंग टू इच अदर बट ड्यू टू द ऍक्शन ऑफ heat they will partially deform and they will combine with each other as a permanent one. So ceramics are the material which are going to be produced due to heating process. Okay, ceramics are the materials which are going to be produced due to the heating. That's why if you see whatever the beakers and all that you use in the labs and all, they are made from the ceramics and we can use them in a hot atmosphere as well. Because already it is made due to the action of heat, the material is going to be prepared, so we can have the application of the same. So here you can see that it is defined as inorganic compound consisting of metals and one or more non-metals. Some of the examples are given: silica, alumina, and more complex compounds such as hydrous aluminum silicate. The main ingredient is mostly clay product. So basically, we have to understand what is ceramic. It is nothing but inorganic compound consisting of metals and non-metals. But I have given a simple example of earth pot. It is a kind of ceramic material. Okay, here the soil or powder particles are going to mix together, and after why heating is required or why? Because its strength increases. If you just cool it in the sunlight, it will not have that much of strength. But if you heat it to certain temperature, like preparation of the bricks as well, okay, that is also going to be a part of heating process. So ये हीटिंग करने की वजह से क्या होता है जो भी पाउडर पार्टिकल्स पहले उसमें क्या होता है कि वो पानी की वजह से और बाइंडर होगा शायद उसमें कुछ उसकी वजह से एक दूसरे को पकड़ के रखते हैं बट उसको अगर हीट करते हैं हम लोग हीट करने की वजह से वो पार्शियली डिफॉर्म हो जाते हैं और पार्शियली डिफॉर्मेशन होने की वजह से वो एकदम एक दूसरे के साथ एकदम पक्का फिक्स हो जाते हैं इसलिए उसका स्ट्रेंथ बढ़ता है और जब आप वो खरीदने जाते हो तो यू आर आल्सो डूइंग वन ऑफ द नॉन डिस्ट्रक्टिव टेस्टिंग दैट इज सोनिक टेस्टिंग आप उसको वर्क पॉट को ऐसे बजा के देखते हो अगर उसका साउंड एकदम क्लियर आता है दैट मींस दैट इज गुड एज फार एज स्ट्रेंथ इज कंसर्न if the dull sound is there that means that it may break in few days like that from that we will decide which one to take. Okay, so that is the kind of ceramic materials definition you can go from here. Silica is nothing but the silicon oxide, SiO2, the main ingredient in most of the glass products. जो भी glasses यहाँ पे बनते हैं, जो भी कांच बनाई जाती है, उसमें हम silica as an ingredient we can add, and that is one of the most important or main ingredient in that. Alumina is nothing but Al2O3. It is also used for various applications from abrasive to artificial bones. From alumina we can have artificial bones also, and abrasive means you might have seen that double disc polishing machine in the lab. In that, abrasive particles of alumina or particles of alumina are used for the fine polishing of the steel material. For the fine polishing of the steel material, the powder is in the form of paste. The disc is rotating, sample is there, you have to just put the water on that, some water, and just put the alumina particles on that particular disc and polish the material. Your fine polishing will be done. So, why fine polishing is happening? Because these alumina particles are very hard and strong. They will just remove the material from the surface and you will have the polishing of the steel like a mirror image. You can see your face in that particular surface if you do the fine polishing or final polishing with the help of these alumina particles. So that's why they are abrasive in nature, and more complex compounds such as hydrous aluminum silicate, the main ingredient in most of the clay products. So here is classification of the ceramic system, all silicate ceramics, oxide ceramics, feldspathic ceramics, glass infiltrated ceramics, and also polycrystalline ceramics. So in silicate, glass phase, crystalline phase, metal oxide, no or reduced glass phase, Vita Mark 1, Vita Mark 2 likewise. I will not ask a question on this kind of flow chart, but there may be question on polymers flow chart. Properties of the ceramic, if you see, hardness. Ceramics are hard. Ceramics are very, very hard and wear resistant. Wear resistance is also good. So hardness is why? Because again, just I have told you that due to the action of heat, the particles are going to be deformed partially and they will connect with each other like permanently, and that's why your hardness is going to be increased. अभी hard है तो brittle भी होगा, मटका ऊपर से डाला तो टूट जाएगा, है ना? 2 मिनट में टुकड़ों में बिखर जाएगा. That means that fracture is kind of a brittle fracture, and we know that the material which is having high hardness, it is equally brittle as well. So brittleness is also high. They tend to fracture without much deformation. Then high compressive strength. The material which are strong, the material which are having high hardness, they are considered as a brittle one, and the brittle materials are very good in compressive strength. Tensile strength may come होती है उनकी, but compressive strength अगर, that's why bricks, example of bricks. Why these bricks are going to take the load of entire floors? They are brittle in nature. Bricks are brittle in nature. That brown colored bricks, they are brittle in nature. That's why their compressive strength is good. Whenever you see the world famous builders or well-known builders, they used to test their bricks for the compression test. In the civil department, we have that compressor testing machine. While the construction of this particular building, we have tested that bricks for the compression in our lab only. Okay, the cement block जे बनवले होते आपण, त्या cement block ची compressive strength आपण lab मध्ये check केली. Okay, so that is the material which is brittle in nature. It is always having a good compressive strength. Like हमने cast iron के बारे में भी देखा. Cast iron is having very high strength because carbon content is ranging from 2% to 4.3%. So as carbon increases, hardness increases, brittleness increases, but at the same time, compressive strength also increases, tensile strength decreases. So they are also having good compressive strength, low tensile strength, high melting point. Al2O3, pure aluminum लोगे आप, it may be soft and it may have low melting point. But उसके साथ oxygen रहेगा, alumina रहेगा, Al2O3 रहेगा, it becomes very hard and its melting point also increases drastically. That's why alumina is more stronger and tougher, and it is also having higher melting point as well. And that's why it can be used for removing the steel material in case of abrasive polishing. In case of abrasive polishing, that alumina particles can be used as a polishing particles in that case. Low thermal conductivity. Okay. चाय पीते हो आप, चाय कप ऐसा पकड़ते हो तो आपका हैंडल गर्म होता है क्या कभी? हैंडल गर्म होता है ज़्यादा? Means what? Whatever the heat of the tea is there in the cup, that material is not conducting that heat towards the handle, and you will feel comfortable while taking that tea. So they are very bad, not very bad, but bad in thermal conductivity also. They are having low thermal conductivity. Thermal shock resistance. Thermal shock resistance is what? It is varies some ceramics like polycrene and designed to resist the sudden temperature change. Thermal shocks means if the ceramic material I am using for certain application, and if there is a certain or there is a continuous fluctuation in the temperature, in that condition also my ceramic material is giving the properties, giving the performance. The properties are not degraded. That means they are having thermal shock resistance as well. So they cannot. The properties are not going to be compromised due to the temperature fluctuation or temperature changes, frequent temperature changes. Insulating materials, we can use them as insulating materials. Okay. The end of example, when high voltage carrying wires are there on the pole, you might have seen that brown colored part under the cable and above the pole. Able to imagine? समझ में आया क्या बोला मैंने? जे बाहेरच्या हाय व्होल्टेज करंट हाय व्होल्टेज कॅरिंग वायर्स आहेत त्या डायरेक्ट पोलवरती जोडलेल्या असतात का? कशावरती असतात? ते सिरेमिक कलर ब्राऊन कलर पार्ट असतो त्याच्यावरती ते रेस्ट करतात आणि मग खाली जातात. दॅट मीन्स whatever the current flowing through that particular wire is not getting transferred to the pole, है ना? पोल को मिला तो काम तमाम, ठीक है? So and अभी किसी ने अभी खेती वाले लोग वायर तुटून जर हाय वोल्टेज वायर तुटून जर खाली जमिनीवर पडली ती दगड पिघळवते. It will just melt the rock. That much power is there, that much temperature is there in that, and that much current and voltage is there. So this kind of insulation is must for electricity carrying and all that. So they are also used as a insulating materials. Some piezoelectric materials are. What do you mean by piezoelectricity? Lighter. Example is lighter. Sir, आम्ही कुठे वापरतो नाही. मी थोडे बघायला आलो तुम्ही वापरताय का नाही. बरोबर ना? म्हणले साहेब. So some of the materials responds to the applied stress. लाइटर कैसे हीट कैसे आती है, आप दबाते हो और फ्लेम आता है. तो due to the application of the force, the flame is going to be there. So that is piezoelectricity. Can generate the voltage when stressed. जब आप बटन दबाते हो तो वोल्टेज जनरेट होता है, वोल्टेज जनरेट होने की वजह से फ्लेम आती है. Okay, so that is a good example of piezoelectricity. Is nothing but lighter. Superconductivity. Some advanced ceramics exhibit superconductivity at low temperatures, corrosion resistance, and chemically inert. They are chemically inert means they are not going to react with any chemical material or any heavy chemical solution during their uses as well. So ideal for use in aggressive chemical environments such as biomaterials. Some of the ceramics products and their applications are also mentioned here. यहाँ पे क्वेश्चन आ सकता है, just discuss the properties of ceramics. Define ceramic and discuss the properties of the ceramics. So this much properties we have to discuss. Then some of the ceramic products and their applications. Typical product and their application. Clay construction products, bricks, clay pipe and building tiles. Refractory ceramics, that means the material which is used at high temperature. Capable of high temperature applications such as furnace walls. जो हमारा furnace है लैब में आपने देखा, that furnace walls are made from this ceramic bricks. Then cement used in concrete, used for construction and roads. Then whiteware products like pottery, stoneware, fine china, then porcelain and other tableware based on mixture of clay and other minerals. Chinese जो आपके dinner set वगैरह रहते हैं, that is one of the best example of this whiteware products. Then glasses are there, bottle, glass, lenses, window panes and light bulbs like window glasses are also kind of a ceramic material. Glass fibers is there, thermal insulating wool, reinforced plastics, then fiber optic communication lines. फाइबर आप वाईफाई के बारे में अभी देखते हो ना, आजकल वाईफाई पहले केबल के थ्रू होता था, अभी बोलते हो फाइबर्स के थ्रू, फाइबर लाइनिंग. Okay, so that is one of the example of this one. Abrasives, cutting tool materials, ceramic insulators are also there. Application include electrical transmission components, spark plugs. Spark plug देखा है कभी? Spark plug के सामने जो whitish material होता है, that is made up of ceramics. White color का जो रहता है ना spark plug के आगे, मतलब जो knob ऐसा आता है, जहाँ से spark plug होता है, that is also made from the ceramics. Then magnetic ceramics are there. Computer memories like your hard disks. Hard disks are made from the ceramic material. Okay, 1 TB, 2 TB, like whatever the capacity is. Then nuclear fuels based on uranium oxide. इसके लिए अभी world war चल रहा है. Why America is interested in Iran war? Because America wants their uranium, whatever the ores are there. और यूरेनियम फैक्ट्री जो है, यूरेनियम के ऊपर उनका भी ये है, क्योंकि only Iran is having I think that source and they want that source. America want that source. But अभी ऐसा हुआ है, क्या है कंडीशन अभी वार का? हमारा क्या है हमें पता नहीं. आप वर्ल्ड वार की बात करते हो, हाँ? वो थांबवत आहे का नाही? कधी थांबेल युद्ध? नाही थांबत. मग सर आम्ही फक्त ऑनलाईन कधी होतं याची वाट बघतोय ना. युद्धामुळे ऑनलाईन कधी होते कॉलेज त्याची वाट बघतोय. पण असं काय होणार नाही. ठीक आहे. Then bioceramics are also there, artificial tests and bones. Here are some categories of the ceramics. Traditional ceramics, new ceramics and glasses. So traditional ceramics comes under the category like clay products such as pottery, bricks, common abrasive and cements. New products that more recently developed like oxides, carbides with better mechanical and physical properties. And some glasses are there, can be based primarily on the silica and distinguished by their non-crystalline structure. So glasses are also coming under the category of ceramics. Here you can see the oxide ceramics. Primarily made up of metal oxides like FeO, iron oxide or any metal oxide you can have. Oxide ceramics are ceramic materials composed of primarily metal oxides. These ceramics are stable at high temperature, chemically inert and typically act as an insulator. So whatever the oxide ceramics are there, they are chemically inactive or they will not react with any chemical solution with that. So that's why they are having application in chemical storage as well. Okay. Then they are chemically inert. They are typically acting as excellent insulators. Because no heat and electricity can be conducted through that. That is nothing but the insulation. Then they are also stable at high temperatures as well. That's why they are found the applications in furnace walls or some big furnace walls where the bricks of furnace wall where the operating temperature is always more than 1000 degrees Celsius like that. So high temperature applications are also there. They are widely used in structural, electronic and biomedical and thermal applications. Although included among traditional ceramics, alumina is also produced synthetically from bauxite. Alumina can be produced synthetically, means man-made polymer kind of thing from bauxite. Through control of particle size and impurities, refinement in process methods, blending with small amount of other ceramic ingredients, strength and toughness of alumina are improved substantially compared to its natural counterpart. So only alumina if you take, only Al2O3 if you take, you may have a less strength. But if you control the particle size of that alumina particle size is going to be controlled. That means if you have a fine particles, like fine grain material are having more strength than the coarse grain, we have learned that already. But यहाँ पे अगर आपके alumina particles are fine, in that case you may have chance of improving the strength. Impurities, refinement in processing method. That means if there is any impurity inside that particular one during the process, you have to remove that impurity as much as possible so that the strength is again going to improve. Blending with the small amount of other ceramic ingredients, like जैसे हमने स्टील की स्ट्रेंथ बढ़ाने के लिए या टफनेस बढ़ाने के लिए अलग एलिमेंट डाले, like molybdenum, tungsten, these अलग element we have added to improve the strength. Similarly, we can improve the strength of alumina by putting some ingredients into that particular one. Then strength and toughness of alumina can be improved substantially. Alumina also has good hot hardness. Hot hardness means at high operating temperature, hardness is not going to be reduced. The material will maintain the hardness even though the operating temperature is high. So that is hot hardness, low thermal conductivity and good corrosion resistance. So these are some sort of properties of oxide ceramics you can call it as. Here are some images of the oxide ceramics. I am not going in detail with that. And here are some types of oxide ceramics. Alumina is there, zirconia is there, magnesia, beryllia, titania and silica. Al2O3, ZrO2, MgO, BeO, PiO2 and SiO2. Their key features: high hardness, Al2O3, high hardness, wear resistance and good electrical insulation. Applications in cutting tools, insulators and implants. Like we can have pits as well, or you can have bones made from this particular aluminum oxide ceramics or alumina oxide ceramics. Zirconia, you can see high fracture toughness, good thermal shock resistance, dental implants and oxygen sensor. अभी आप रूट कैनल करने जाते हो, कैप बैठाने जाते हो तो वो लोग बोलते हैं जिरकोनिया की कैप है इसलिए महंगी है, इसलिए महंगी है, या सिंपल मेटल वाली कैप है इसलिए वो सस्ती है. So likewise, zirconia is having application in dental implants as well. Magnesia, excellent thermal conductor and high melting point. refractories and crucibles. Crucibles are made from magnesia or MgO because they are having high melting point, so we can use them to heat something inside that and putting it into the oven. For heating purpose, we can use the crucibles. Then this beryllia is high thermal conductivity and electrical insulators. It is used in electronics, aerospace, used continuously due to toxicity, cautiously due to toxicity. It is a kind of toxic oxide, so we have to take care while using of that particular one. Then titanium, high refractive index, then photocatalytic, so pigments, solar cells and sensors, and silica, glass formation, thermal shock resistance, optical fiber glass and insulators. So in one table only I have given the types of oxide ceramics, their key features of the oxide ceramics, and some of the key applications of the oxide ceramics. Again the question will be, give types, key features and applications of oxide ceramics. लेक्चर कोणाचं आहे? आले सर आले लवकर येऊन थांबते माणूस. Attendance will be taken in the last lecture. आता नाही गेलं मी शेवटच्या लेक्चरला गेलं. Any problem? Stop.